Good morning, good afternoon, good evening. The topic of this particular lecture or discussion is to extend our understanding about how markets adjust to changes in demand and supply. And you know from looking at the market model that if demand increases, then price goes up, quantity goes up, just X marks the spot, shift demand out, and so forth. But the next logical thing to investigate is, well, when demand increases, does price go up by a lot, or does it just go up by a little bit? Or when price goes up, do people cut back a lot on what they're buying, or do they just cut back a little bit? You're measuring the magnitude of the quantity adjustment to a change in price, whether it's buyers or sellers. And then later we'll look at the magnitude of the adjustment to a change in income, or the magnitude of adjustment to a change in the price of a complement or a substitute. Good. So just briefly to go back through markets, they are the interaction of buyers and sellers. We focus on these models separately, and we use this technique of ceteris paribus, isolating one factor at a time to build our model of behavior. We know demand is the schedule of the quantities buyers are willing to buy at different possible prices. Supply, again, the other model, a tracing out of the quantities that sellers are willing to produce and sell at different market prices. And by the way, just stop for a second and think about that. Price is always market price. Anytime you see the word price, it means market price. And remember that from the buyer's point of view, that's a bad, right? That's what you give up to get the good. And so you'd like to get it to be zero, right? And from the seller's point of view, price is what they receive in the marketplace for producing and selling their goods and services. So price is a positive to them. It's what's coming into them as a result of their activities. And consequently, they would like to have an infinite price. Sellers would like to get an infinite price for their goods. Wouldn't you love to work and get $1 million an hour, right? How long would you work? That last 10 minutes is rough because you already have $800,000 to spend. Good. So the two groups have totally diverse desires with respect to market price. But we noted as we overlay the two functions and look at the interaction that takes place between buyers and sellers, that there are predicted adjustments that result from certain kinds of situations. If the price is above equilibrium, above X marks the spot, then you have unsatisfied sellers because there is a surplus of the goods. Buyers are only willing to buy 300. You guys brought 1,100 to market. And so there's stuff left over in the sellers. And because we're assuming competition between the sellers, price is going to get bid down. Price is going to get bid down. There's plenty of people who've never seen a demand curve who exist in the marketplace, and they know if there's stuff left over, the only thing to do is lower price, right? They know the only way to sell more is to offer it at a lower price. As the price comes down, notice both groups adjust. At lower prices, the sellers are not willing to produce as much, so the quantity they're producing is going to decline. As price comes down, the buyers respond by being willing to buy more because the relative price of the good is lower. But as long as you're above that X marks the spot, competition will drive the price down to that equilibrium level. If instead the market opens up by mistake and sellers think that the price is going to be 25 cents, then they would be willing to bring 200 to market, and at that price, buyers would like to buy 850 units. And so, as you know, that's called a shortage. It means that the buyers are unhappy, at least some of the buyers are unhappy, because the market failed them. The market did not bring to market a number adequate to satisfy the buyers that are there in the marketplace. Once sellers see that, then they know they can raise price, and that's what they always wanted to do. As the price goes up, they're willing to produce more because they can sell it for a larger amount. As the price goes up, buyers are not willing to buy as much. Quantity demanded is declining. But as long as you're below equilibrium, that competition between the buyers will drive the price up. So markets will adjust to the equilibrium price. Markets will adjust because of competition on both sides of the marketplace. And the equilibrium, we know, is the price that quote, clears the market. Sometimes it's called market clearing price because the rate of production, distance to supply, 600 units, just matches the rate of consumption. Distance to demand is $600. And that is called the equilibrium price. The equilibrium price, because at that point, there's no incentive for prices to change. If sellers were to raise price, they'd end up with a surplus. And they have no incentive to lower price because they can sell that quantity at the price that they're currently charging. So it's also an equilibrium in two ways. It's a balance of the rate of production to the rate of consumption. And it's also a situation in which there is no inertia for things to change. Things have settled down so that unless demand or supply change, the plans of the two groups are being coordinated correctly. Total revenue is price times quantity. So on the graph, we're assuming it's reached equilibrium. So total revenue would be the equilibrium price times the rate of consumption and production, or this area, which is $30, and it is price times quantity. So total revenue is always price per unit times number of units being exchanged. By the way, in your notes, that's also called the exchange value of the good. The exchange value, meaning the dollars that flow from the group of buyers to the group of sellers. And then, and this is where we get into market dynamics, and I did some of this probably last week. We now want to identify the effects on the equilibrium price and quantity when these factors shift. When these factors change, we want to be able to predict what happens to the price, what happens to the quantity. So an increase in market demand, rightward shift, we can see would lead to a higher price and a larger quantity. Now, turn it around backward. If you read an article and it says that the price is higher and they're selling more units, you know what's happened. Demand's gone up, right? There's no other shift that will give you that same combination, right? And so if you're reading about something or you're reading an industry study and it says prices are up and people are producing more, then you know demand's gone up. And then, understanding demand, you can try and identify why it went up. You guys with me? Because then you can start thinking about, is it taste and preference, income, price of substitutes or complements? Everybody with me? See, that's now you're putting these things together in a way to investigate what's actually happening in the marketplace. Increased price and increased quantity if demand increases. Again, ceteris paribus, you're assuming nothing else is changing. The effects of an increase in supply. Well, again, an increase is a rightward shift. We can see that an increase in supply would lower price and increase the quantity being bought and sold. So combining now, looking at price changes up or down, if price goes up, what are the possible explanations? Well, one we've already said is an increased demand. That would cause price to go up. The other is a decrease in supply. That would cause price to go up. So if you only know that price has gone up, you don't know precisely what's happened, but you know it's one of two things, or both. Everybody with me? If price is higher, either demand's increased or supply's decreased, or both of those things have occurred. So you're beginning to be able to know something. If you now know quantity, then you can tell which it is. If quantity's higher, what's happened? Demand's increased. Good. If quantity's smaller, what's happened? No. Quantity smaller. Supply's decreased, right? Good. And then, as I said, once you know that, if you know both of the variables, then you can look behind them to see, well, why is that the case? Why did supply decrease? Well, it's because there was this giant hurricane that just destroyed the entire productive island of Puerto Rico, but increased the demand tremendously for electric wires and plywood and all kinds of other stuff. Finally, it is the interaction of demand and supply that determine the equilibrium price. But But to understand the dynamics of the marketplace, you want to understand that demand determines price. And that's a phrase you want to put like in all caps, underline, put stars around it. Demand is what determines market price. It's not the cost of production. It's what people are willing and able to pay for that particular good. If demand is at D1, you'd have this price and quantity. If demand increases, then the market would adjust. Sellers would raise price and produce more. And if demand increases again, it pulls forth more production. Price has to rise to cover the additional cost of those resources. So it is demand that determines price. I think I may have spoken about this in the previous lecture, but I often wanted to put up a graph. I wanted to put up a display that has like 150 demand and supply curves all over the thing. Just visualize, just demand, just a whole bunch of them all over the thing. Because that's what the market really is. The market is all these individual demand and supply for various goods, and then they're all interrelated. They're all interrelated, right? I mean, like the demand for Florsheim shoes is affected by what Hush Puppies do with their shoes, and so they're all interrelated. So a change in one will have these ripple effects. Some other markets affected a lot, some other markets not affected, but it's this amazing adjustment process, and I marvel at how this system is self-regulating. It's self-regulating because in every market, the market adjusts to the equilibrium. The market goes to the equilibrium, which solves the problem. There are many mathematical models that explode. There are many mathematical models that if you change something, then the whole thing falls apart. And markets are what is called a self-equilibrating system, because in each case, the adjustments lead to changes that lead to that new equilibrium in the marketplace. And just all of the specialization and all the different jobs that people have, and it's midwinter, it's 22 degrees below zero, and there are fresh oranges in the grocery stores in Duluth, Minnesota. Everybody with me? I mean, it's truly amazing the way this stuff goes. I interviewed I had a conversation with a Frito-Lay delivery guy about, his deliveries in the Valley, obviously, and he delivers all kinds of Fritos. There are all these different flavors. There's the hot ones, and then there's probably sour cream and cheese. I don't know, but there's a whole bunch of different flavors. But he was pointing out to me that they know the taste and preference of all these different regions in the Valley. And for example, the super hot ones, he only delivers like 10 bags to Encino, right, to the 7-Eleven in Encino. But in Pacoima, like 80% of the ones they sell are the super hot Doritos, or whatever they were, Fritos. So it's just truly amazing the way the system adjusts and how it all coordinates and then like stop signals, like the traffic system. You have these little devices that have different colors, and two roads want to share a space. And so as I get there, if the light's red, that means I don't have the right to use the space, and your light is green, it means, okay, you guys can use the space. And then when it turns yellow, you're not supposed to speed up and race through. You're supposed to slow down and stop, although we all do that. It's really a tight calculation, isn't it? Yeah. It's changing like, okay, how fast am I going? How far away am I? Can I make it through? And and then on freeways, it's amazing. The freeways, cars are going like 65 miles an hour, and people are trying to get on, and it works. It works like a zipper, basically, right? Like, cars, and then the cars allow you space, and if you come in at the right speed, it's just truly amazing that the whole system really does function. And maybe I'm easily amazed in my old age. So I mentioned to you at the beginning, we're trying to measure the responsiveness of quantity to a change in price. So I've drawn two supply curves here, A and B. And remember, quantity is measured horizontally, and quantity adjusts to changes in price. So which of these two would reflect a more responsive supply, A or B? Quantity's horizontal, so a steeper curve would mean what? A smaller change in quantity. A flatter curve would mean a bigger change. Good. So B is more responsive. And you can draw in a price change to see that. Price goes up, A, quantity only increases a little bit. Same price change for B, big increase in quantity. So a flatter curve represents a more responsive quantity to a change in price. More responsive quantity to a change in price. You get a job working for a financial analyst company, and they want you to put together some line graphs for the changes in price of one of their assets, which is a stock, over the last 10 years. So change the notation a little bit. Make the horizontal time, years, and make the vertical the price of the stock, and see what's happening over time. So you put in your Excel spreadsheet, and you put the data in, and you say line graph, and it comes up with B as the line graph, showing the change in price of the stock over time. You show that to your boss, and she said, well, that's not very impressive at all. That's not impressive. I mean, it shows that it went up, but it's not very impressive. She takes the same data set and changes the units of measure on the graph. So instead of over there, a year is this far, she changes it to this far. Everybody with me? And then on the vertical axis, a change in a dollar over there was this much. She changes it to this much. Good. Plugs it in, and she gets this graph. Everybody see it? The problem with slope is that it's sensitive to the units of measure that you're using. And by changing the units of measure, you can change the slope. And so this looks much better over here. And the slide's only up for about 10 seconds. And so you say, well, you can see the XYZ company has done relatively well over the last 10 years, and they've been growing in profitability. Next slide, right? Good. For that reason, slope is not sufficient to be an unbiased measure of responsiveness to changes in price. And then secondly, even aside from looking at one particular item, if I wanted to compare the responsiveness of two different products to changes in price, the slope's going to depend upon what unit of measure I employ. If I'm doing pencils, I could do price per unit, or price per dozen, or price per gross. If I'm doing oil, I could do price per ounce, price per gallon, price per barrel. And so economists said, well, we need to find a way of finding a measurement that is unit-free, finding some way of measuring responsiveness that is unit-free. And this is the same thing for demand. This shows high responsiveness, flatter curve, a steep curve, less responsive. So economists came up with this measure called, I just did that, called the elasticity of demand. The elasticity of demand, a measure of responsiveness of quantity to a change in price. When you hear the word elastic, not demand, just elastic, what does that mean?
Stretch.
Stretches, good. What?
More than one.
Well, no, it just means stretches. It may be more than one, or it may be less than one, but it just means it does stretch, right? I'm about to get to your point. If it stretches a lot, then you'd say it's what? Very elastic, right? If it stretches but not very much, you'd say it is inelastic. Y'all with me? Those are our terms that break up the amount of adjustment relative to the change in price. And the simple way of calculating it is to take the percentage change in quantity and divide by the percentage change in price. And you can calculate it on the demand side, you can calculate it on the supply side. Percentage change in quantity demanded divided by percentage change in price. Filling in how to calculate the percentage change in the simple manner, the percentage change in quantity would be the amount of change in quantity divided by where you started from. If I said to you, and the same thing for price, the simple calculation, percentage change in price would be the actual change divided by the starting point, the price that I started with. If I said to you price was $1 and it went up to $1.10, what's the percentage increase?
10%.
See, you all knew that automatically, right? You didn't even have to think through a calculation. Everybody with me? You all said right away, 10%. Good. But what you actually are reflecting is the amount of the change was 10 cents. The starting point was $1, so you divided through, multiplied by 100, and that gave you the 10% increase. Everybody got it? Good. The problem with this, and this is called point elasticity, because you're measuring the change from a particular starting point. The problem with point elasticity is that over 2 points on a demand curve, or a section of the demand curve, if I start at the higher price and calculate the elasticity moving down, I'm going to get a different number than if I start at the lower price and calculate moving up. Everybody with me? Because you're picking an endpoint, that changes the calculation of the number, right? One of them uses a higher price as the reference point. One of them uses a lower price as the reference point. So if the two observations are at a price of 4, you buy 120, at a price of 6, they only buy 80, then if I take it from A to B, the lower price to the higher price, the calculation would be 33% divided by 50% or minus 0.66. Bless you. If I start at B, so $6 is the reference point and 80 is the quantity reference point, then I get negative 1.5. And so by measuring from either endpoint, I get a biased estimate of the relationship over that. Notice that it is negative, and it's negative because demand is downward sloping. The elasticity, the price elasticity of demand is always negative. You with me? A raise in price increase leads to a decrease in quantity. So the sign of the ratio would be negative. A decrease in price, right, negative, would lead to an increase in quantity. So again, the sign of the relationship would be negative. Good. So it's always negative because it's downward sloping. It's an inverse relationship. So instead of using the endpoint, we use the midpoint as the reference point in the calculation. And this is referred to as arc elasticity or midpoint elasticity. By taking the midpoint of the two quantities, which would be Q1 plus Q2 divided by 2, and taking the midpoint of the two prices, P1 plus P2 divided by 2, then no matter whether I'm going up or down, that reference point's the same. Y'all with me? If I use arc elasticity, I've eliminated this problem of the bias of an endpoint. And so in either direction you calculate it, you're going to get negative 1. In either direction, you're going to get a number of negative 1. So for your calculations in solving problems or talking about elasticity, always use the midpoint formula. Always use arc elasticity in your calculation. With me? Okay. Good. Now, going to your point that you were mentioning before, if it is true that the numerator, which is the quantity adjustment, is bigger than the denominator, then we define demand as being what's called elastic. So we say demand is elastic if the quantity adjustment is bigger than the percentage change in price. If that's the case, the absolute value, meaning the magnitude of the number, is going to be bigger than 1. And it's because the quantity adjustment is bigger than the price change. I lower price by 10%, I sell 20% more. What's the elasticity? Lower price by 10, that's the denominator, that's a negative 10, and I sell 20% more, that's the numerator. What's the number? Good, negative 2, right? Negative 2. And it's negative 2 because the 20% is bigger than, it's twice as much as the change in price. That's when demand's elastic. I raise price by 10%, I lose 50% of my sales. Well, then demand is very elastic. And that would be an elasticity of 5. If the two are the same, if when I lower price by 10%, I sell 10% more units, then the number is going to be 1 the ratio is going to be 1, right? Because it's 5% divided by 5% or 10% divided by 10%. So the actual size of the number will be 1, and that is called unitary elastic. Unitary meaning 1. The reason elasticities are important, going back to elastic, if demand is elastic, lowering price increases total revenue. Think about it. I lower price by 10%, I sell 20% more. So I've lost 10% in the price, but I've increased the number sold by 20%. So total revenue goes up. If they're highly responsive and I raise price, I lose a lot of revenue, right? Elastic means they're very sensitive to price changes. Good. So when demand, if demand is elastic, when I calculate it for my product, and I discovered that the number is bigger than 1, then I know lowering price will increase the revenue coming in. Now, I don't know about profit yet because if I sell more, I have to produce more. Everybody with me? Profit's total revenue minus total cost. Total revenue will go up, but because I'm producing more, total cost will also go up. So in that direction, I'm not positive about profit, but I am positive about total revenue. It's just straight mathematics. Good. If instead it's unitary, then in fact it's a wash. I raise price by 10%, so I get 10% more money from the buyers. But I lose 10% of my sales. Total revenue doesn't change. Everybody see it, right? I cut price by 50%, so I'm getting 50% less dollars, but I sell 50% more units. It's a wash. Total revenue is unaffected when demand is unitary. And in fact, you could go beyond that and suggest that the closer you are to 1, the smaller the change in total revenue, right? The bigger it is, the bigger the change. The closer it is to 1, the smaller the change. If it is the case, when I raise price, that I lose less than that percent in quantity sold, then the number is going to be less than 1, because quantity is in the numerator, price in the denominator. If the quantity is smaller than the denominator, if the quantity adjustment is smaller than the price change, then you're going to get a fraction as a result. I raise price by 20%, and I only lose 10% of my quantity. So what's elasticity? 20% on the bottom, 10% on top. What's the number?
Half.
Yeah, half, right? Just solve for that. Good. So the number would be 1/2. Well, that means demand is inelastic. The quantity was smaller than the change in price. If demand is inelastic, meaning that when I raise price, I lose a smaller percentage of the sales, then increasing price raises total revenue. Increasing price raises total revenue. Think about it. I raise price by 20%, so I get 20% more on the ones I sell, but I lose 10% of my sales. I'm still better off, right? The additional 20% outweighs the loss of 10% of the sales. So when demand is inelastic, raising price always raises a total revenue. And if demand is inelastic, it also raises profit. Does everybody see it? Profit's total revenue minus total cost, right? I raise my price and I get more revenue in, but I produce fewer units. If I produce fewer units, what's happened to total cost? Come on, guys. If you produce fewer, what happens to total cost? Goes down, right? Good. And so an individual firm would never knowingly price if demand in the region where demand is inelastic. You'd never knowingly do that because you can raise price and make more profits, right? Everybody with me? Good. Elastic, highly responsive, lowering price, increased total revenue. Unitary, it's a wash, right? Equal, equal. Inelastic, raise price. So on a straight line demand curve, the upper portion is the elastic region of demand. The upper portion. Because if you look at, here it is. Because if you look at drawing a flat demand curve, flatter than 45 degrees, visually extend that out to where it meets the axis, you are on the upper half. Everybody see it? if you extended that demand curve all the way out till it meets the axis, that's part of the upper half. And notice when it's elastic, lowering price increases total revenue. So you can draw a graph that will represent elastic by drawing a flatter graph. If instead demand looks like B, or over there, extend that demand curve up, you're on the lower half. And that's the range where demand is inelastic. Raising price over there would in fact increase total revenue. So in working through graphical problems, it's easy to do. Draw a flat curve, that's elastic, right? Draw a steep curve, that's inelastic. And the same is true for supply. A flat curve would mean a big quantity adjustment, elastic. A steep curve would mean a small quantity adjustment, inelastic. Now, the reason it's important is that understanding the relative elasticity of demand and supply determines how big the price increase is when demand changes, or how big the quantity change is when demand increases, depending upon the elasticity of supply. So what I've drawn is a very elastic supply curve. I've drawn in what looks like a unitary demand curve, and we just look at how the two are affected. Increased demand, rightward shift, price goes up by a little bit, but quantity goes up by a lot. Everybody see it, right? And the reason is that it doesn't take much of a price increase to pull forth a lot more production. It must be the case that they have lots of resources that are very similar to the ones they're using. Demand increases, they're able to expand production without too much additional cost. If instead I drew an inelastic supply, steep curve, the same change in demand, notice what the effect would be. Demand increases, price would go from the initial equilibrium up to the new one, so you get a big price increase, and the quantity increase is much smaller, just a small quantity increase. So when supply is inelastic, changes in demand cause more price fluctuations than quantity changes in that way. Do the same thing for changes in supply, looking at elasticity of demand. Here, buyers are very responsive. Decrease in supply leads to a little bit more price, but a big reduction in quantity. And again, the reason is buyers respond quickly to changes in price. Or if I draw an inelastic demand, then in fact the opposite's the case, like it was before. The decrease in supply causes a big increase in price and a small decrease in quantity being produced. This would be an example where the firm is close to capacity, and so its supply is very inelastic in the short run because it can't increase the rate of production very easily. It takes a big cost or a big price increase for it to be worthwhile for them to, if something causes them to have to produce less, it takes a big price for buyers to adjust to that smaller quantity. What would you guess is true about the elasticity of demand for gasoline as a product? As a product, not at one station, but all gasoline. When gasoline prices change, do you change the amount you buy a lot? No. In fact, it's really the case that when you go in to fill up, you may only glance at the price, right? And the price might be $2.62, and then next time it's $3.10, and then it's $2.90. I mean, it bounces around somewhere in that range. But you don't tend to change the amount you buy because demand's very inelastic, and I'll talk about why that is the case. Consequently, small changes in supply lead to big price effects. Big price effects. And what happened with the hurricane in Florida, was that Irma? Yeah. It greatly reduced the supply. Number one, the refineries that are there in the area that normally would have provided the gasoline for that area shut down because of the storm. So the only way to get gas in was to bring in the million-gallon tankers from up above. And prices went up a lot. Well, they went up a lot because a small change in supply leads to a big adjustment in price in that way, because it's very valuable in that way. Good. So the question then is, what are the determinants of elasticity? What factors would cause demand to be highly responsive or not very responsive to changes in price? The first is the number and closeness of substitute products. If there are lots of close substitutes, demand's very elastic because it's easy for you to adjust. We both mentioned and you agreed that the demand for gasoline as a product is very inelastic. And the reason is there are not a lot of close substitutes for the major use of gasoline, which is transportation. When I teach at USC, I normally teach at 8 o'clock, and so I have to leave the valley by about 6:45 to get in front of this large number of cars that come down the 101. And if I leave at 6:45, I get in front of most of that mass, and I can get down in about a half an hour or 40 minutes. If I leave at 7, 15 minutes later, then that whole mass has already passed the 101. I mean, you know, where it goes across. And then it's like 50 minutes to an hour and so forth. But what I observe is, as I drive on these freeways, almost every steel cage, which is what cars are, has one person in it. You all with me? I mean, there are all these cars going down this road, and almost all of them only have one person in it. The reason is there are very few close substitutes to driving yourself. If you drive yourself, when do you leave? Whenever you want to. And where do you go? Precisely where you want to. And you control the temperature, the humidity, the music, and the scent of the trip, right? If you take a train or a bus, when does it go? 15 minutes after it's scheduled to go, right? Where does it go? To some bus stop, which probably is not right in front of your building. And you cannot control the temperature, humidity, or scent of the trip. You can control the music now because you have so those are not close substitutes in the minds of most people. And so they prefer to be driving by themselves, and that makes demand for the product very inelastic. Secondly, you have to know about the substitutes in order to switch. And so when you go down to the gas station level, what would be true about the elasticity of demand for a specific Shell station? Would demand for that station be highly elastic or inelastic? Station is at the corner of White Oak and Sherman Way. It's a Shell station. Are there many close substitutes? Oh, yeah. Thousands, right? I mean, not hundreds, right? There's one right across the street. Good. So for the individual gas station, demand is extremely elastic because there are very, very close substitutes. Are they identical? Excellent. Good. No, they're not identical, but they're very, very similar. The regular gas is actually probably the same gas. It comes from the same refinery. The difference is in the additives that they put in for the plus and then for the super. They use different additives on different ones. But they're very, very similar. But they're not identical. You know, what are the other characteristics of the sale? Well, one is how pleasant is the clerk, right? And how easy is it to get into the station and out of the station? I read a marketing study about 8 years ago, and they were talking about different taste and preference of men and women for gas stations. And they were saying men prefer Mobil and women prefer Shell. And then the argument was the following. What is the symbol for Mobil? What's the symbol? Flying horse. Flying horse called Pegasus, right? And they used to have it on the station. They used to have a depiction of it. And it is this massive testosterone animal, right? Like the muscles are bulging out of it and so forth. What's the symbol for Shell? Shell. It's a little shell, right? And at night, when you're tired, you can close the shell and you're safe at home, right? So women prefer Shell, you know, design over Mobil. Color schemes are different. Shell has, what colors?
Yellow.
Mostly yellow with a trim of red, right? Mobil has what? Yeah, white with the trim of blue or red or something, a little bit like that. So the argument was that women prefer this because yellow is a warmer color, and the shell can be closed at night to be safe. So I read the article. It's like, yeah, right. So I was filling up where?
Mobil.
At the Mobil station. Good. And I looked across the street, and there are all these women at the other Now I shop at the Shell station. But it is, yeah, like you solve the problem. So it is interesting. There are differences, but they're very, very similar. So demand is very, very elastic for that product. Third factor is the amount of your income you're spending on the good, the percentage of your income that you spend on the good. If something's a very small percent of your income, demand tends to be inelastic because, you know, chewing gum goes from $1 to $1.25. Do you chew a lot less gum? Probably not, right? Well, that's a 25% increase, right? If they raised tuition at CSUN by 25%, would there be a big quantity adjustment? I suspect there would be, right? The bigger an item is as part of your income, the more elastic demand is. And think about it, it makes sense. The more something is as a percent of your income, the more you invest in looking at substitutes, right? Because it's worth it to do. When you buy a car, you do extensive looking at substitutes. And so demand for any one car is much more elastic than the demand for a car, period. My son runs a consulting firm up in Santa Barbara, and he designs websites and he does commercial art and logo design and, you know, brochures and all that kind of stuff. And he has all different kinds of clients. One of them is a tropical fish store, in Santa Barbara, the Johnsons. And then one of them is Verizon. And both of them occasionally want to change the page that's being posted. And so I said, what are you charging? And he said, $50 to change a page. And I said, put the following in place. If you want it changed, it's $50 and it's 5 to 7 business days, right? If you want it done in 2 days, that's called express, that's $100. If you want it done overnight, that's a super express, that's $200. Y'all with me? Good. The Johnsons are the elastic demanders. They can put the picture up anytime, right? They can put it up a week and ahead of time. It's a fish of the month, and they change it once a month. Verizon wants to update their coverage maps. When do they want them posted? Immediately, right? And the $200 is a tiny fraction of their $1 million budget for advertising. So it's a small portion. They're the inelastic demanders. You raise price to them. The Johnsons are elastic. You lower price to them. In fact, you guys see this all the time on Amazon, right? With delivery, right? Standard delivery, 5 to 7 days, you know, $5. If you want it in 3 days, it's $20. If you want it tonight, it's $72. That means that if you want it tonight, you're the inelastic demander, right? You're like, I don't care what I have to pay. I want to have it right away. Yeah.
Is that what you call price discrimination?
Absolutely. Yeah, yeah. In fact, that is the key to most forms of price discrimination is different elasticities, and then you match to them. Yeah, and we'll do a model on that later on. Finally, the amount of time following the price change, the longer it's in place, the more elastic demand is. The reason is over time you have more knowledge about substitutes. Over time there tend to be more substitutes, and over time you can change the complementary package of goods. Gas goes up to $7 a gallon. You have 1 year left on your lease. So you'll probably drive the SUV less, but you're probably not going to cancel the lease, right? Once the lease is canceled, that's the long run. Then you're going to buy a car that gets more miles to the gallon. So your quantity adjustment would be bigger in the long run when you've had a chance to change the complementary package of goods. There are people here in the Valley, there are people here in LA who drive from Thousand Oaks to downtown LA every day. They commute from Thousand Oaks all the way downtown, hour and a half each way. They drive 3 hours a day, right? 3 hours a day of their life, every day is spent in a very unpleasant activity of trying to keep up with all the other cars who are stupid and stuff. By the way, if you drive after 11 p.m., you should be aware that 70% of the people on the roads are drunk. Y'all with me? They're intoxicated. Maybe they're not drunk. Oh, you can just Google it. It'll show up. I mean, it's just a true fact. I think it's like 9 o'clock. right? And then at 1 a.m., it's probably like 98%, including you in that, right? Good. Now, this is what I wanted to get to, so I want to get through this. Good. There are other elasticities besides price elasticity, but price is the big one for a lot of what we'll do. But you can measure the responsiveness of quantity purchased to a change in other factors in the same way. So you can measure what's called the income elasticity of demand, the responsiveness of quantity to a change in income. So the calculation is the same. Quantity adjustment's always in the numerator. In this case, the independent variable is percentage change in income. If it is a normal good and your income goes up, do you buy more or less? Normal good. More. Good. What would be the sign of the elasticity? Positive. Good. Increase in income, increases quantity, positive relationship. Good. If it's an inferior good, when income goes up, quantity adjusts in what direction? Down, right? Inferior good. And so that would be negative. That income elasticity would be negative. And then the size of it tells me how substantial is the response to changes in income. We noted before, Starbucks is very responsive to changes in income. And here are some examples. Clothing is like a 10%. It's like unitary elastic. Stereo systems, high elasticity, income elasticity. A 10% increase in income leads to like a 30% increase in expenditures. Not additional numbers of units, but in quality that's purchased. This was a study that was done at some point. Yeah. Good. I'm also interested in how responsive is my demand to a change in my competitors' prices or in complementary prices. So that is called the cross-price elasticity of demand. I'm measuring the effect on the sales of good number X in response to a change in the price of some other good. So it's my quantity response in response to a change in my competitor's price or in a complement's price, right? Good. For substitutes, it's a positive relationship. As they raise their price, I sell more units. Everybody with me? Good. So cross-price elasticity for substitutes is positive. It's negative for complements. If they lower their price, then I sell more units. So it's a negative or inverse relationship for that. Uses of cross-price elasticity, as we said, it measures the magnitude of response to my competitors or complements changes. It allows you to identify who are your closest competitors by calculating the substitution effect on various price comparisons. And the courts use how big that cross-price elasticity is to define market power of the firm. And then market power has different antitrust laws of activities that you're allowed to do if you have a large market share or a small market share. Good. Now, all transactions involve costs of doing the transactions. Now, this is very important, and it's not in the text. This is my stuff, but you have to know what I'm talking about. When you buy something, when you first move to a new area, how do you find out where stuff is?
Google.
Today it is Google, right? What's the other method, though?
Walk around.
Yeah, good. Drive around, right? Drive on the highways, the streets, right? Good. As you drive on the streets, what activities do sellers undertake to make you aware of their location? Signage, right? Signage. Good. And there are these big neon signs, right? Big signs that say, here's Vaughn's, right? And if you know Vaughn's is a grocery store, then you know, okay, I can buy groceries here. Good. That is called search cost, the cost of identifying where goods are for sale. The second information cost is identify what is the quality of the good. Estimate what is the quality of the good. For avocados, you see how soft they are. For watermelons, you thump them. For a stereo system, well, you might go online and read all about the different substitutes. CNET is an excellent website that compares electronic devices. But you're going to investigate alternative quantities to get a better feeling for the value to you of having a particular unit. So those are those exist in every transaction. Sometimes it's simple, sometimes it's very complex, right? Sometimes you invest a lot of money in quality identification. The next category is called negotiating cost. That is the cost of coming to an agreement between the buyer and seller of what will actually be exchanged and when. You don't negotiate with the checker at Ralph's. You don't say, well, I know it says $2, but how about if I give you $1 for this tube of toothpaste? Then it's security, right? But in many, many business transactions, particularly, the negotiating costs can be quite substantial because, as I was pointing out to you, in those kinds of business relationships, you want to draw up a contract that makes it very clear what the responsibilities are of both parties. When I joined this consulting firm, there were 5 people, and Ben was a great economist, and I was executive vice president by the 5th year, and the lease was coming up for renegotiation, and I said to Ben, I want to hire Michael, who'd been coming around. He's a commercial real estate guy, and I'd gotten to know him and stuff. And Ben said, no, we don't need him. He said, we did really good, me and Rick. You know, we got these things and we got these things and we did really well. And I said, I'll tell you what I'll do. If he doesn't save us more than the amount that he costs us, I will pay the difference, right? Now, what I should have said is the second part is, but if he does, you pay me the difference, right? Well, this guy knows all the contracts. He's dealt with Catherine, who's the person at the building, all the time. They give you what's called a boilerplate contract. And boilerplate means unchangeable. Y'all with me? The term boilerplate means this is what it is. Now we can negotiate these points in it, but the boilerplate is the legal language of the lease. So Catherine gives this to Michael. Michael says, no, that's not, here's the contract, right? Because he knows there are other things that you can adjust. He got us build out money on a renewal. Build out money is what you get to build out the space when you first move in. There's no build-out cost for us. We're already in, right? But he got us the build-out money because if he rented to somebody else, you'd have to pay him that. He got us a 7-year lease lock-in as opposed to 5 years, and there was a whole bunch of other things. So the side point of this is hire experts to do these kinds of things. Hire experts to do these kinds of things. But anyway, negotiating costs, coming to agree what will in fact be exchanged. Finally, there is transportation cost, and that's simple. It's the cost of moving the two goods in the exchange. We use credit cards now, which greatly lower our transportation cost in that direction. Y'all with me? You just give them the number, and the money gets transferred to them and stuff. And then Amazon, and I'm a Prime member, has negotiated transportation costs, and you can get different levels depending upon how much action you have with that particular party. So you really want to know all 3 of these, because if you can find ways of reducing the transactions cost to buyers, then you can increase sales. If you can find ways of making it easier for the buyer to identify the quality of your product or the location of your product, or reduce negotiating costs by offering certain kinds of guarantees and so forth, then you can greatly increase profitability. Good.